All right, so very good afternoon to everyone. A very good afternoon to all of you, and I welcome all of you to the session in which we are going to deal with the motion in a straight line. And today we are going to deal with the topic of motion under constant acceleration, that is, motion under gravity. Okay. Okay, so guys, see, in the last session, so first of all, let me introduce myself. My name is Dr. Umashankar, and I'm your physics educator. And I have completed PhD and MTech from IIT Roorkee. These are my few basic qualifications. I have qualified the GATE examination. I have been into 11 years into teaching of physics, and I authored three international papers, research papers in the field of mechanical engineering, and also I am a author and editor to some reputed scientific journals. Okay. Okay, so this is my brief introduction. So let's get to the point. So guys, in this session, so till now what we have completed. So basically now we, with this video, we are going to change the pace also. Okay, so basically, so basically what happens. So basically, what happens? So till now, what we have done? So we were doing two things together. So firstly, I'll tell you where we are right now. So we are into kinematics. We started the kinematics, and we are seeing two zones in kinematics. One is motion in a straight line. Okay, motion in a straight line. Okay, and motion in a plane. Motion in a plane. So as for our syllabus, as per NCERT, we are having these two things. Okay, in kinematics, one is a motion in a straight line, another is a motion in a plane. Okay. Now, in motion in a straight line, we have done a few things. We have learned about like what are the basics, what is this distance, what is displacement, what is the speed, what is velocity. Okay, what is the speed, what is velocity, right? Okay, what is the speed, what is velocity, how to make graphs of graphs in kinematics, like how to draw displacement time graph, from displacement time graph how to interpret this, velocity time graph, from velocity how to reach to the acceleration, from acceleration how to reach to the velocity, right? All these things, guys, we have done previously. Okay. Okay, and also we have derived some equations of a motion. Okay, now motion in a plane, so for that we have completed the vectors. Okay, you can find all the vector section in the channel. So vectors we have done, this is the part of a motion in a plane, because like to understand motion in a plane, like projectile motion, circular motion, we require the information of vectors. So vectors is completed, and a straight line till we have done with the graph. In kinematics differentiation integration, we have developed the equation of the motion. Okay, so in today's session, okay, when I say the motion under gravity, so the same concept you can be using for the motion under constant acceleration. Both are the same thing, more or less. Okay, so we will apply the concept here. Okay, using the popular equations of motion, and we'll learn how can we deal with the problems involving the gravitational acceleration. Okay, so motion in a straight line. So what are the equations we are having? What are the equation we are having? So u is equal to v plus at, u is equal to v plus at, s is equal to ut plus half a t square. Okay, okay, and v square is equal to u square plus 2as. Okay, these are the equations, guys, that we have derived previously, and basically we are going to use these equations, okay, to understand the motion, to deal with the problems of the motion. Further, these equations are going to be used in the projectile motion also, right? Okay, when we call about motion in a plane, so these are widely used equations. Okay, and let me write it here. So equations of motion, this is what we have derived previously, equations of motion, right? Now in the case of equations of motion, guys, so what we have dealt with, so we have the equations as v is equal to u plus at, okay, s is equal to ut plus half a t square, and v square is equal to u square plus 2a s. Okay, v square is equal to u square plus 2a s. So v is what? V is final velocity. Okay, u is what? U is initial velocity. Okay, a is what? A is the constant acceleration. Remember, I told you previously also that these equations are only applicable. These equations are only applicable when the acceleration is constant. So A is constant, beta. You know, A is constant. Okay. And what is S? So remember, S is not the distance, but it is the displacement. And displacement, we know it is the shortest route, shortest distance between the initial position and the final position, right? Okay, okay. So see, using these equations, we are going to deal with the motion under constant gravitational acceleration, or motion under constant gravity. Motion under constant gravity, right? Okay. Now, how we are going to deal with this? Now, when we say motion under gravity, okay. So see, motion under gravity, like the questions that you see that like a ball fell from a top of a building, or you throw a ball from a top of a building or from ground, it reaches this height, that height. So that all comes under motion under gravity. So motion under gravity, it means that we are dealing into uniform acceleration, because we understand that the gravitational acceleration is constant. Okay, so when we say uniform acceleration, that means constant acceleration. Are you getting my point? Now, in this, what happens? See, you are going to use these equations only. The only difference that comes up here is A is equal to G. That is, A is equal to G. Okay, so we understand to use these equations like in a normal basis. Okay, the only difference comes when you are saying that motion under the gravity. So only difference comes up that you are going to use the acceleration equal to the acceleration due to gravity, that is g, and we know that g in general is 9.81 meter per second square, right? This is the general expression. This is a general, value of the acceleration due to gravity, right? Okay. Okay. So sometimes for ease of solving the question, we may consider g is equal to 10. Okay. Don't mind it. Right. Okay. Now let's talk about it. So under this condition, see, please understand this. Under this condition, see what happens. What happens that the motion happens to be under constant acceleration, that is under the gravitational acceleration. Okay. So now v is equal to u plus at, okay, s is equal to ut plus half a t square, v is equal to u square plus 2as, v is equal to u square plus 2as. So these are the equation. Now please understand this. I'll give you something. So this is nothing new. This is the same equation that we use. Now please understand this. See, I'll give you some sign convention. See what happens. So this sign convention will be helpful, because you may see a lot of questions are coming from this very zone, that this ball is thrown upward, this ball is thrown from top of the building or something like that. Okay, now under those conditions, what happens that we are going to use this concept. So I'm going to give you some sign convention, okay, using these equations, okay, and then we are going to apply it, and will be very easily be able to deal with the problems of acceleration due to gravity. Okay, v square is equal to u square plus 2as. Right. Now please understand this. What is going to happen here? Now please understand this. So now we are going to deal with the sign convention. Okay, we are going to deal with the sign convention. Okay, so we'll be using these signs for ease. So see, very simple, very simple. So let's suppose this is your reference point, maybe ground or from where you are taking the reference. Good afternoon, Uzma. How are you doing, beta? So, beta, today we are starting with the motion under the constant gravity. Okay, I'll just give you a brief here. So, see what I was speaking about, that we are into, as you know, that we are doing motion in a straight line, motion in a plane together. So, vectors is completed in the last session, and motion in a straight line in the last motion in a straight line session. We dealt with the graphs in kinematics, and before that, we have derived these equation of motion, right? I'm very sure that you must be aware of these equations. Okay. Now motion under gravity. So here equation of motion. So few things to take care of. So here v is equal to final velocity, u is the initial velocity, a is the acceleration, and remember one thing, that these equations are only applicable under constant acceleration. Okay. Okay, and s is the displacement, that is the shortest distance between the initial position to the final position. Understood, Bila? Okay. Now, motion under gravity, it is nothing new. Okay. These equations are going to get used. Okay. Next, we'll be coming up with the projectile motion also. Projectile motion is also nothing but use of these equations in some sense. Right. Okay. So this topic is going to be the basic of understanding of projectile motion also. Okay. Now, only difference here is that when we say motion under gravity, so the acceleration, that constant acceleration that we are talking about, we take it equal to g, that is acceleration due to gravity, and whose value is what, 9.81 meter per second square. But sometimes for sake of simplifying the calculation, we may take g as 10 meter per second square. I hope it is fine to everyone. Okay. Now understand this. So when we are using this equation, so basically when motion under gravity, so if someone is moving like from this point to this point, will gravity do anything to this? No, sir, of course not, because we understand that gravitational acceleration always acts in this sense. Okay, so gravitational acceleration has nothing to do when someone is moving in a horizontal path. Okay, okay, it only comes into picture if something is moving in vertical direction. Okay, so I am telling you some sign conventions using which we can very easily solve any problem which comes under motion under gravity, and this will give you the basic of solving projectile motion also, and also the simple problems in which constant acceleration is involved. Okay, now please understand this. So see, whenever we are seeing some motion, we can see from some reference. Like for example, if I say that there is a building, okay, there is a building, right, and this is your ground. Okay, so this is the top of the building. This is the top. Now someone threw a ball from this top. Okay, someone may have thrown the ball from this top. So obviously it will follow somewhat like this path, isn't it? Yeah, I'll come to it. Just listen to me. So in this case, like you can take the reference if you considering the motion is started from the top of building. So you can take the top as the reference. Are you getting my point? For this motion. Okay, reference point. Okay. Now from the reference, this line shows you the reference. Now from the reference, see, simple, if any of the quantity, and whether it is s, u, v, anything, if it is in upward direction, we'll take it as positive. If it happens to be in downward direction, we'll take it in negative. Do you agree to it? Okay, for each and every quantity, no confusion at all, right? Like for v, for u, for a, for t, for all the for all the vectors here. Oh, so t has no direction, sorry. What is the direction of t? T is a scalar, na? All the vectors v, u, a, s, we are going to take up this, sign convention, that from some reference, if it is in upward direction, we'll take it as positive. If it is in downward direction, we'll take it as negative. Is it fine to you? Okay. Now, very interesting thing. If we are following this sign convention, beta, now do you agree to me that acceleration due to gravity, that is g, is always downward. So here A is G now, because we are talking about the motion under constant gravitational acceleration, yeah, motion under gravity. So acceleration is equal to G, and G is always downwards. G is always downwards. So if G is always downward, beta, in whole of this topic, in whole of this discussion, you do not to use any of your mind. Whenever you are using G in any of this equation, you must always use minus G, isn't it? In the whole of this discussion, when we say motion under the gravity, no matter what problem you are solving, what reference you are taking, gravitational acceleration is always downward. So the sign of this gravitational acceleration that we are going to use in this equation is going to be minus G. Do you agree to this or not? Please answer me. So you need to forget everything. Just do one thing. You just forget everything. You just follow this sign convention. Okay. You just follow this sign convention. Okay. Okay. So always follow. Forget everything. Just follow this. Okay. As you. Okay. So it can be upward. It can be downward. So anything which goes up, any vector which is in upward direction, it is going to be positive. Any vector going in downward direction from any reference, it has to be negative, and G is always negative according to this sign convention. No trouble at all. Now let's try to apply this. We'll be solving some question here. Okay, so let's say a body is thrown. I'll just make one question. A body is thrown vertically upwards. A body is thrown vertically upwards with 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 some speed. Let's say with some speed. Okay. Now with some speed u, or I'll just write with speed u. Okay. Now what you need to find? So let's start doing it. So first find the time taken by it to reach maximum height. The time taken by it to reach maximum height. Okay, let's try to do it. Let's try to do it. Can you try it? No data, no numerical values given. Just let's do it in using some general terms. Okay, so that we come to understand it, how we can apply some concept. A body is thrown vertically upwards with speed u. Find firstly the time taken by it to reach the maximum height. Let's try it. Let's try it. Use the same sign conventions. We'll be able to do that. No worries. Please go for it. Please go for it. Hmm. Seems incorrect. No, no. Yeah, seems incorrect. See, I'll do it. This is the first question. I'll do it this part. Let's try. You do the next part. We have lots to do. Don't worry. So let's try to figure this out. Ha. No, again wrong. Time taken by it to reach the maximum height. No, please listen to me. Next part you'll do. Okay, don't worry. So let's think about it. That what is the question? So it says the body is thrown vertically upward with some initial speed. So let's take the reference. Please understand this. Let's take the reference. So let's suppose this top of the building is our reference point. Okay, this is our reference. Now it is thrown upward with some initial velocity u. Okay, the initial velocity is u. Okay, Now, do you understand this? That what happens to it? Now, please figure this out. So, it will go to some height, and at some height, its velocity will become zero for the instant, and then it will start moving downward. Do you agree to it or not? Obviously, sir. So, if you think of it, if you imagine the situation, if you are throwing a body or a ball or something like that from some height, from some top of the building or from anywhere, it is going to definitely reach a particular height. Okay, it is going to definitely reach a particular height, and afterward it is going to fall back. Okay, now see, let's suppose that this is point A, this is point B. See, whenever you are applying these equations, beta, you have to be very clear about that between which points you are applying this. No, no, Uzma. See, always you need to give the answers in the terms which are given in the question, right? So you have given some 2h. So h cannot be. See, any h is mentioned in the question? No, sir, not at all. Now please observe. Now please observe. Let me do this question. Afterwards, the next question. We have a lot of questions to do. Don't worry. Now, first tell me yes or no that do you agree to this that this body will go up to a certain height? This body will go up to a certain height, and from that height, it is going to start its downward motion. So, if I consider the motion between A to B, if I consider the motion between A to B, see, let's process the information that we have between A to B. So we have the initial velocity. Okay, what is the initial velocity? U, right? See, we have three equations, and also this is also very, very important that we understand that which equation we have to use at in what condition. So initial velocity is with us, that is U. What is going to be the final velocity at B? What is going to be the final velocity? Final velocity at B. Okay, so this is the motion is from A to B. So obviously the reference we are taking is from A. Okay, okay. So final velocity is what? It is zero. It is zero because at B, at the moment it reaches the maximum height, it will momentarily come to a stop. Okay, it will stop for that time point of time because if it is not a stop, it would have been moving upwards further. Na? See, you have thrown a body upwards. Okay, so it has stopped at some point of time. So that means at that moment, its velocity becomes zero. Yes or no? So the final velocity is zero, and you need to find the time when you have the acceleration. So acceleration is minus g. Please understand this. The initial velocity is plus 5. How it is plus 5, sir? Because it is upward direction, so plus 5. Final velocity is 0, and acceleration is always negative. When it is g, motion under the gravity, it is always negative. So a is equal to minus g, a is equal to minus g, and we need time. So see, you have the initial velocity, you have the final velocity, and you have to find the time. Now, what is the equation we must use out of these three? So, sir, we have final velocity, initial velocity, we have acceleration, we require time. So, obviously, the first equation we must be using. So, if I use the first equation, v is equal to u plus at, always put this sign convention. So, v is 0, u, initial velocity is u, plus a is equal to minus of g, a is equal to minus of g. And let's suppose this time is t1 because we'll be calculating further times also. So let's suppose this time is t1 because see, obviously it reaches some height. It took some time. Now it will take some time to get back to the original point of throwing the ball or to the ground. So let's call it t1. Now from here, t1 is equal to u upon g. Do you agree or not? Please answer me, beta. T1 is equal to u upon g. So if u is in meter per second, g is always in meter per second square. This will come into second, isn't it? We'll take care of the unit later. Yes or no? Please answer me. See, we have used the sign convention simply. We have used the equation of the motion. Which equation of motion is to be used? So when we have initial velocity, when we have final velocity, okay, when we have the acceleration, we need to get the time. So obviously we must use the first equation, v is equal to u plus at, right? Wonderful. Okay. Now let's try one more part of it. Let's tell me, so what is the maximum height? What is the maximum height? What is the maximum height uh, it takes, maximum height from top of the building? From, oh, so here, top of the building is not mentioned. Okay, chalo, no problem. So from top of the building, or let's write the maximum height. Okay. Okay, so let's say this is the ground only. I have taken the top of the building. I don't know why. Let's suppose this is your ground here. What? Or maximum height from top of the building. From top of building. Okay. Let's try it. Okay. Let's do it. No problem. Let's try to solve this. Please think. I'm very sure we can do it. No problem at all. Please go for it. Wrong answer. Wrong answer, beta again. See, it is not that difficult. I'll do it. You want to try again? See, you don't have to think here. You just have to apply the equation. First question, what is C? First question that come into your mind to solve this. Out of these three, which equation is to be applied? Okay. Whenever see the motion is happening under constant acceleration, you have these three equations. So the first thing that shall come in your mind that to solve this problem, which equation I shall apply? Okay. Okay. That's all. Yeah. Please try again. Please try again. See, we have to give sufficient time to this. Okay, this is the basic of projectile motion. Right. Afterwards, we'll start with the projectile motion soon, and that is going to be very, very useful for you. So we already have the time with us. Now you need to find the maximum height from the top of the building. Please go for it. Please try it now. Don't worry, take some time. No problem at all. Very, very simple, madam. Very, very simple. Yes, you may use the second equation. Why so? Why you need to use the second equation, beta? See, very, very simple thing. You please try to understand. See, maximum height from top of the building. That means you require the displacement. See, this h is the displacement. Okay. And you have initial velocity. Okay. You have initial velocity. You have time. So you can use this equation. Okay. You can use the third equation as well. See, I'll do. No worry. Let's apply the first. So again, we are considering the motion from A to B. Again, we are considering the motion from A to B. So we have initial velocity and we want to have this displacement. So H is the displacement now. But displacement is what? It is the shortest distance between initial position to final position. Now let us apply this equation. S is equal to ut plus half a t square. Okay, half a t square. Now please tell me one thing. From reference point we are moving upwards. Okay, so let's say that s is plus h. Why I am using this plus sign? Because we know all the vectors from reference, if they are in upward direction, this is positive. I hope this is fine to you. So s is equal to plus h. Now what is u? Again, this is the initial velocity in upward direction, so I may use plus u. Now t we already have calculated. This is equal to u by g. Okay, u by g plus half. Now this a is minus g. This a is minus g because this acceleration, gravity. Yeah. And if from second equation, from third equation, from any equation you do, you are going to get the same answer. It's the matter of that what you are using at this place. Like I am using the second equation. See, I'll be using the third equation. Just now I'll be using the third equation. Don't worry. So now as we have put u, we have put, and acceleration is minus g we have put, and t we know is already we have calculated u by g whole of a square. U by g whole of a square. Now from here, what is going to be the h? It is u square by g minus u square by 2g. See, 1g and g will be cancelled out. So u square by g minus u square by 2g. So that is going to be the maximum height. Yes or no? That is going to be the maximum height from the top of the building. Is it fine, beta? Okay. So when you use this equation, can you tell me what mistake you have done? I'll be just doing it from the third equation. See, it shall be done with the third equation. You said the second equation. So see, all these equations are complementing each other. Na? Okay. Now, if at all, see, please think in this way, what I'm trying to tell you here. So if at all, if in this question, there is no first part, only this part, that what is the maximum height from the top of the building. So you must directly use the third equation, because if you use this equation, firstly, you have to use the first equation to get the time. Are you getting my point, Bida? Okay. Okay. Now let's apply this one. So what is the best way? Best way. It is u, what is the equation? V square is equal to u square plus 2as. Now this final velocity 0. Initial velocity, since it is upwards, so it is plus u. Then the a, it is g is always downwards, so it is minus g, and this is displacement s. So from here, s is going to be u square by 2g, or we'll write h. So h is upwards, so we'll write plus h. So h is going to be u square by 2g. Did you get it or not? Just in a blink of eye you can do. What was the mistake that you were making here? So all the other live students, welcome to the session. Beta, we are seeing the motion with the gravity today. Okay. So let's add one more part. Now, what is going to be the time taken by it to reach back the top of the building? Right? So now what we are, acha, you did it right. Wonderful. So the time, no, initially you were saying u square by g, na? That is what I'm asking. Initially you were saying that g square by u square by g. So you must have made some mistake there, na? So time taken by it to reach back the original position. Now what is going to be this? Can you get me the third part? Can you give me the third part? Acha, acha. Okay, that was typo. No problem. No problem, beta. Now, time taken by it to reach back the original position. See, very, very simple. Very, very simple. If you want to do the third part, so what is going to be the time taken for it to reach back the original point of throwing? So let's suppose this body is being thrown from here. So if it goes here from A to B in T time, now it can reach back from B to A. It can come back from B to A in again that T time. Are you getting my point, Vida? Because we are assuming, so this happens when we assume that there is no air resistance, no air friction. Are you getting my point? No such thing. Okay, so simply by conservation of energy, you get this, isn't it? Okay, okay. So like if nothing is mentioned, we always ignore the air resistance. But in practical, there is some drag, some friction by the air. Okay, okay. So what is going to be the time it requires? So from A to B, then from B to A. So it will take 2 T na. Okay, time taken by it to reach back the original position, it is going to be 2T. So it is going to be U square by G. It is going to be U square by G because a small t is U square by 2G. A small g is equal to U square by 2G. Is that fine, beta? Please answer me. Please answer me. Please answer me. Yeah, yeah. Now I want to show you something. Okay. Let's suppose that we have any, confusion in this. Sir, how it happens? Okay. Now please understand this. Let's do it in another way. Okay. Just look at me. Now let's suppose this is your original position. Now, yeah, I'm explaining again. See, please understand. No, I'll explain like this. Okay. First of all, see, this body is thrown from the top of the building, so it will follow a path like this. It reaches the maximum height. Now from A to B, now going from A to B, it took T time, right? Do you agree or not? Okay, it took T time. Now coming back from B to A, coming back from B to A, it is again going to take the same time. Okay. So from initial position, when you are throwing something under a given acceleration, okay, and it reaches to some point. Now from that final point, if it is to reach the initial point, it is going to take the same time. Na? Law of conservation of energy says so. Let's suppose you don't know it. Sir, I don't believe. I don't believe on this. Let me do it with the formula. Okay. But later on, we can see in NEET, we don't have this much time now. So we can, from the next time, use this concept directly. Now, let's suppose what happens. Okay. Let's suppose what happens. So something goes from A to this point B. And now from B, it came back to A. It came back to A. Okay, from B it came back to A. Now see, I can use these equations of motion from an initial position to final position. Now I used to take what I taken previously. So I have taken the motion from A to B. Then if we take the motion from B to A, so let's not do it. I am taking the motion from A to A. See, initial position. What is the ultimate initial position? So ultimate initial position is the top of the building. And at the end of the ultimate end of the motion, at the ultimate end of the motion, at the ultimate end of the motion, it reaches back to the top of the building. Right? Okay. So I am considering the motion from A to A. A to A. And now please see, this is the shortcut. You can save a lot of time. Now, when we say this equation S is equal to UT plus half AT square, can you tell me what is the displacement? Okay, what is the displacement? And let's suppose this T is the total time. total time it took from A point to come back to A point. So what is the displacement when it moves, it goes from A and it came back to A? What is the total displacement? What is the displacement? Can you answer me? What is the displacement, beta? What is the total displacement? Can you tell me? It is zero. Okay, it is zero because we very well know that displacement is the shortest distance from initial to final position. So can I put s is equal to 0? Yes, sir, of course. Then this is u. This time is the total time it took. So let's call it t. Okay, and this u direction. So initial, from initial position, the initial velocity is upwards. So we can take it as plus u. T plus half. So acceleration is always, yes, very good, Rima. So acceleration is minus g because when we are having the motion under the gravity, the g is always downward. So this is minus g and this is t square. This is t square. Are you getting my point? Please answer me. Now from this equation, can I write t? If I take t as the common, I'll be getting u plus g by 2 g by 2, sorry, u minus g by 2 of this t. Yes or no? Please answer me. Bole. Did I miss something? Can I write this way? U minus g by 2. Yes or no? Okay. Okay. Now this is equal to 0. So see, t is equal to 0, t is equal to 0, and t is equal to 2 times t. T is equal to, so if I solve this equation, we'll have, see, if I solve this equation, we have, so can I write it like this? 2u, okay, let's write like this. U minus g by 2 of t is equal to 0, right? No problem at all, sir. Now, when we solve this equation, we are getting, sir, t is equal to 0 and we are getting t is equal to u minus g by 2 of t is equal to 0. So, we are getting t is equal to 2u by g. Do you agree or not? Please answer me. Oh, I have written u square by 2g. I have taken, I have written it u square of, oh, t was u by g, na? So this is 2u by g. Sorry, my bad. This is t is equal to, we have solved t1 is equal to u by g. So 2t is equal to 2u by g, right? Now, similarly, we are getting the same thing. T is equal to 2u by g. Do you agree or not? So we are getting two values. We are getting two values, 0 and 2u by g. So why we are getting two values, beta? We are getting two values because this particular body comes to this, in the whole duration of this motion, it reaches this position twice. One is when the time is 0 because when the motion has started, and when it again reaches back to the same point. So you are getting the same thing. So from here, see, you get, so we already derived this t1, na? T1 is u by g. So t you are getting 2 times t1. So that means whatever time it takes from moving from A to B, it took the same time to come back to B to A, right? So from the next time onwards, we'll be using the same concept. And here I have written u square by g. That is wrong. It is 2u by g. Okay. I just saw this by mistake. Okay. So it is u by g. T1 is u by g. So it is 2u by g. Understood, beta? Please answer me. Please tell me yes or no. Did you get this concept or not? How to use the equations of motion? Please answer me. Please answer me, beta. Yes or no? Let's do some more questions if we are comfortable in this question. Did you get the concept, all of you? Yes or no? The live students, please answer me. Very important concept. See, these all things we'll be using in the projectile motion too. Easy, na? Let's solve some more questions. Okay. No theory at all. See, physics is not having much of theory, and I'll keep it very fast from now onwards. See, we have learned vectors comprehensively, so now we have to finish the syllabus also. So I'll be a little bit, considering many concepts. फिजिक्स कैसे पढ़ें? देखिए, ऐसे ही पढ़िए बेटा, क्वेश्चन सॉल्व करके, कॉन्सेप्ट समझ के। देखिए, मैं बस इसमें आपको एक, देखिए, ये तो सबकी अपनी अपनी कहानी है, ठीक है, कि कौन कैसे पढ़ेगा। लेकिन जैसे मैंने पढ़ा है, जो मुझे ठीक तरीका लगता है वो ये है कि बेटा आप कॉन्सेप्ट पे ध्यान दें, ठीक है, चीज़ों को सिंप्लीफाई करें, है ना। फिजिक्स आपका बर्डन कम करता है बेटा, आपकी प्रिपरेशन के लिए, ठीक है। आप केमिस्ट्री बायोलॉजी में एक तरीके से कह सकते हो खूब सारा रट्टा लगाते हो, खूब याद करने की चीज़ें, इसमें याद करने का कुछ नहीं है। आपको कॉन्सेप्ट समझ जाएगा, फॉर्मूला समझ जाएगा, क्वेश्चन अपने आप होने लग जाएंगे। हाँ, निकालो, चलो, आराम से निकालो। ठीक है बेटा। तो जब आप फिजिक्स पढ़ रहे हैं तो हमेशा शुरुआत से पढ़िए। पहला चैप्टर यूनिट्स एंड मेजरमेंट बहुत इंपॉर्टेंट होता है, लोग वही छोड़ देता है, कहता है यार ये क्या पढ़ेंगे, यूनिट तो हमको पता है, मेजरमेंट तो हमको पता है। बस वहीं से कहानी खत्म होना शुरू होती है, ठीक है। फिर जंप करने की कोशिश करते हैं, लाओ सर पार्ट वन फिजिक्स है, लो एक चैप्टर पार्ट टू का भी उठा लें। कॉन्सेप्ट क्लियर होते नहीं है, सब गड़बड़ हो जाता है। आप बिल्कुल एनसीईआरटी के सीक्वेंस में चलें, यूनिट्स एंड मेजरमेंट पहले पढ़ें। सर फिजिकल वर्ल्ड, हाँ वो तो पढ़ ही लीजिए, वो तो हो जाता है आराम से, ठीक है। यूनिट्स एंड मेजरमेंट पढ़िए, काइनामेटिक्स में आएंगे, काइनामेटिक्स पढ़ते पढ़ते थोड़ा वेक्टर्स को भी पढ़िए ताकि आप यूज कर सकें, और सीक्वेंस में पढ़ते जाइए। देखो, मैं आपको एक फैक्ट बताता हूँ, अगर आपको बेटा वेक्टर अच्छे से समझ गया ना, तो काइनामेटिक्स बिल्कुल उड़ा दोगे आप, और फोर्स बिल्कुल उड़ा दोगे, फोर्स से रिलेटेड जो भी चीज़ है। आर यू गेटिंग माई पॉइंट? ठीक है, कोई दिक्कत की बात नहीं है, ठीक है। और पढ़ना शुरू करिए, धीरे धीरे हो जाता है ना, परेशान मत होइए। द सेकेंड क्वेश्चन, ओके, ये राइटिंग बहुत गंदा हो गया क्या? सो स्पीड जस्ट बिफोर हिटिंग द ग्राउंड, हिटिंग लिखा हुआ है द ग्राउंड, क्या कह रहा है बेटा क्वेश्चन में? व्हाट इज says in the question, it says that a stone is dropped from a tower of height 20 meter. So again, some sort of a tower is there, building is there, that height of the building is 20 meter, and you drop the stone from there, you drop the stone from there, and that stone obviously is going to hit the ground, okay. Okay, so the thing is, what is the time taken to reach the ground, and second thing is, what is the speed just before hitting the ground? Please do it. I'm very sure we can do. Please try it, Buddha. Very good. What about the second part of it? Okay, let me do the first part. Have you attempted the second part? Sunil, welcome to the session, Beta. I am from Uttar Pradesh. Though I live in Uttarakhand. My name is Dr. Umashankar. I am MTech and PhD from Indian Institute of Technology, Roorkee. I teach physics from last 11 years. Yeah, those were very good. Okay. So what we are trying to do on this channel, we are trying to complete the physics and biology. Soon chemistry is also going to start on this channel, and we are into kinematics. So we have completed the vectors previously, and we have done motion in a straight line to some extent. Now motion in a straight line will be completed in 2 sessions. So today we'll be completing the motion under the gravity we try to complete, and in the next session I'll complete the relative velocity in one dimension. Motion in a straight line will be finished. After 2-3 sessions I'll take to complete the projectile motion. 2-3-4 sessions I'll take to complete the circular motion. Okay, this is the way we are approaching. So I think within a week or something, kinematics will be finished, and we'll right away start the Newton's law. Okay. Now, a stone is dropped from the tower of height 20 meters. See, always draw a rough diagram, okay, so that you won't make a mistake. Soon will try to increase the speed also. So now see what it says. So a stone is dropped from the tower of height 20 meters. So this is 20 meter, beta. This is 20 meter. Now when this is 20 meter, now this is 20 meter, beta. So now this is 20 meters. So from this point, it reaches. So it is dropped from the tower of height 20 meter, and it reaches the ground. And it reaches the ground. Okay. Now what is the time it taken to reach the ground? Now please understand this. Let's suppose this point is A, and this final position is B. So A to B, we have to go. Now what do we have here? What do we have here? Sir, we have the displacement. That is, now when we are seeing motion from A to B, can I say the displacement is minus 20? Do you agree, sir? How come, sir? Because what is the sign convention we are following? See, don't forget about the sign convention. See, sign convention from reference, if we are moving downward, that is negative. If we are moving upward, that is positive. Okay. So the displacement is minus 20. So time we have to find. Acceleration is what? Acceleration is minus of g. Okay, so let's consider g as 10. Okay, for sake of ease of calculation. Okay, this is minus 10 meter per second square. So we are considering g to be 10 meter per in each and every question we'll consider that. Now we have to find the time. And what is the initial velocity, sir? It is 0 because the stone is dropped from a tower. So it is dropped from a tower. That means that initially it was in the stationary position and it is dropped. So initial velocity is 0. Now when we have displacement, when we have acceleration, when we have initial velocity, we must use s is equal to ut plus half a t square. So this is going to be minus 20. This is going to be minus 20. What is this u? So u is 0 plus 1 by 2. A is minus 10, and this is going to be t square. So we are getting t is equal to 2 seconds here by solving the question. See, minus minus is cancelled out. This is going to be 0 0 cancel out. So 4 t square. So t is equal to 2 seconds. Hello Shizai. Got late today, beta. Right? Yes or no? Please answer me. Right? Very, very simple. Now coming to the next part of this question. Is speed just before hitting the ground. Just before hitting the ground. See, never ever consider that. See, what happens? So sometimes what happens? So when something is dropped, when something is dropped from some height, and when it strikes the ground, many students think that when it strikes the ground, the velocity must be 0. Never consider the velocity to be 0 with the striking. So when it strikes, the velocity is not 0. Okay. Always, when you are using the equation of motion under such circumstances, the final velocity is to be considered to be the velocity that is just before hitting the ground. Understood, Peter? Okay. Now see how we are going to do it. Now again we'll considering A to B. So displacement is minus 20. Displacement is minus 20, so we need to find V. Okay, so what we can do, so this was the first part. Now the second part of the question, it is V is equal to U plus AT. V is equal to U plus AT because time we already have calculated, right? Okay. So V is, what is the final velocity? It is the velocity just before the stone hits the ground. What is the initial velocity, sir? It is 0. What is the acceleration, sir? It is always, so G is always downward, so always minus. That is minus 10. And T already we have calculated, that is 2. So what is the final velocity? It is minus 20 meter per second. Okay. So why the minus is here? What is minus? Why minus is here? So minus is here because this is the downward velocity. Yes or no? Please answer me. So what is the final velocity? It is minus 20 meter per second, and minus refers to the downward velocity. So obviously this direction is downward. Okay. Okay. Understood. Okay. And what is, if I ask you what is the velocity? So if you want to represent in a vector form, it must be minus 2 of j cap, right? Because it says the speed. So you are interested in the magnitude. If they would have said velocity, you must have given it like this. Yes or no? Uh, Usman, this is the badge for everyone, right? This is the badge for everyone. This is not the dropper badge. This is not the topper badge. This is not 11th badge, not 12th badge. This is badge for everyone. Everyone can study here. No problem, no problem, Shizai. See, what we have spoken about today. So we were talking about the motion under constant gravity, and I want to complete it today. So I'll just take a moment to tell you what we have. So you are aware of this equation, I know. V is equal to U plus AT, S is equal to UT plus half AT square, V is equal to U square plus 2AS. Okay, U square plus 2AS. Now please understand this. Now please understand this. So motion under gravity is nothing but the motion under constant acceleration because G is constant. Now I have given you a sign convention that we must use always whenever gravity case comes up. Okay. This is the basic of projectile motion, and I'll be doing the projectile motion using these same sign convention. Okay. So from some reference, whatever vector is upwards, like displacement, initial velocity, final velocity, we'll consider it as positive, like the same way we did in vector. And if some vector from some reference is downward, okay, yeah, no problem. If from reference some vector is downward, we'll consider the negative sign. Okay, so acceleration due to gravity is always negative. It's always negative because acceleration due to gravity is always downward. No problem, beta. No problem. Okay, let's do one more question. Let's do one more. See, these sign conventions are very important. You must not forget it. Okay? Because lately you will be making these mistakes. Let's do it again, some parts. Let's do the first part. So maximum height reached by ball from ground. Let's try this one. Please go for it. Let's try the first part. No, wrong answer. Now it seems correct. What about the rest of you? Please solve it. Uzma, Bima, please try it, beta. Acha, acha. No, no. In this height is asked now, Uzma. 1.25 meter per second, beta. It is the velocity, na. So height. It is the height we are talking about, na. Yeah. Okay, I'll do it. So this is the first part. I'll come up with the second part also. Let's understand this. So our ball is projected vertically upward from a tower of height 20 meter at a speed of 15 meter per second. So projected vertically upward. Otherwise, it would have become projectile motion. Okay, a ball is projected vertically upward. So it is projected like this, vertically upward from a tower of height 20 meters. So let us make one tower. You say why you are getting nervous? Very, very simple questions, beta. Okay, Uzma. Let's see. Let's see. So from the tower, this is projected upwards. This is projected upwards. So this is point A. This is point B. This is point A. This is point B. Right? Now from A to B, so the height of the tower is given. This is 20 meter. Now what is asked, beta? This is asked that maximum height reached by the ball from the ground. Maximum height reached by the ball from the ground. Okay. Now please see what is given. So if I consider, see, two things must be very, very clear in your mind that you are considering the motion from which point to which point. Okay. You are considering the motion from which point to which point. So we are considering from A to B. We are considering the motion from A to B. And what is the initial velocity? The initial velocity is 5 meter per second. Now from A to B, the initial velocity is obviously plus 5 because it is moving upward. Now, when it reaches the maximum height, definitely the velocity is going to become 0. So if I see between A to B, this will become 0. This will become 0. V is equal to 0, right? V is equal to 0. Do you agree or not? And what we want to have, we want to have the maximum height. So we want to have the displacement. A is minus 10, okay, meter per second square, right? This is meter per second. So now which equation we must apply? So sir, we have C, V, we have U, we have A, and we want to have the displacement. So can we apply V square is equal to U square plus 2AS. So V is equal to 0. U is equal to 25 minus, why putting minus sir? Because this G is minus. Okay. Acceleration is in the minus direction. So minus of 2 into 10, I'll write like this. And S we have considered as H. So this H is equal to 25 by 20, that is 1.25. meter, right? Okay, 1.25 meter, is it? Now, please, before answering, you must see the question that maximum height reached by ball from ground. So they are asking you this height, na beta? From the ground, they are saying, na? So from the ground, when they say, so they are asking you this height. So this is 1.25 we have got. This is 1.25. So what is the height from ground? So from ground, it must be it must be 20 plus 1.25, that is 21.25 meter. Please tell me if it is fine or not. Please answer me. Yes or no? Please answer me yes or no. So let's do the another part of it. Let me add one more thing. Sure, let's try to do it. Let's do the second part of it. Please answer me. Very good, Shishai. Mean position is what? What is the mean? So it goes to the top of the tower, then it came back to the tower, and then it reaches the ground, right? Then it will reach the ground. So what is the mean position? So it goes to the top, then it come back to the top of the tower. So this is the mean position. The top of the tower is the mean position from where it is thrown. Mean position means the top of the tower. The time taken by it to reach the top of the tower. So Shisha, you understood it rightly only, no? Uzma, please try to do it. Please try to do it, Vida. No, no problem. Please do watch the complete video lately, okay? Because see, this is the basic of projectile motion. If you won't complete this video, you will face the problem in the next videos, right? Okay, wonderful. So let me solve it now. So now time when it passes from its mean position. So means what? Means what? So let's make the diagram again. So this is somewhat the ground. Yes, yes, she said. Of course, yeah, of course. See, I every day I come up with a target, right? So till this point, I need to complete. So I'll complete it by that point. Don't worry. So now let's suppose this is A, this is B. Okay, this is A, this is B. Okay, this is A and this is B. So now what is the mean position? So the mean position is going to be when it come back from B to A. Okay, when it come back from B to A. So simply what we can do, beta. So see, time when it passes through its mean position. So we can do it in two ways. Firstly, we can find the time it takes from reaching to A to B. And then that same time it will also requiring to reach from B to A. But I don't want you to do this that way. We can simply do it. Now, S is equal to ut plus half at square. Right? This is the formula. Now I am considering the motion from what? I am considering from A to, let's call it A, B, B1, A1. Just for the sake of this moment. So A to A1. A to A1. Right? Okay, ascent time, descent time. See, she said we don't have to do that way. We can do that way also. In the previous question, I did that way only. I told you to do that way only. So A to B, if it takes zero point 0.5 seconds, from B to A, it's again going to take zero point 0.5 seconds. Okay? Okay, but we can do another way also. Now, if I directly apply this equation as is the displacement, now from A to A1, what is the displacement, sir? It is 0. It is 0. Now, from this U, what is the initial velocity? It is plus 5. Okay, meter per second, then T plus half. Sir, A is always equal to minus G under the gravity. It is T square. It is T square. Now from here, can I write T? If I take T common, this will be 5 minus 5 of T. 5 minus 5 of T is equal to 0. Yes or no? So from here, you get T is equal to 0 and T is equal to 1 second. T is equal to 1 second. Now T is equal to 0 refers to your initial position and T is equal to 1 second when it reaches back this position. So what is the time? It is 1 second. Okay. Normally people do like this, that they consider the equation of motion from A to B and then they double up this time. Why to waste unnecessary time? Na? Are you getting my point? Yes or no? I prefer this way. Now is it clear to you or not? Please answer me. Right? I have applied the equation of motion from ultimate initial position to ultimate final position always. Understood? Right? Now let's do one more part of it. Let's say find the speed of the ball. Find the speed of ball. Find the speed of ball just before hitting the ground. Find the speed of the ball just before hitting the ground. Let's try this one. Okay, so you already have tried this. Yeah, wonderful. Okay, so very simple, Vida, again. So we have to find, so let's suppose now this is, it hits the ground C. Okay, okay. So now we have to find the speed of the ball just before hitting the ground. So just before hitting the ground means what? So now I am considering the motion from A to C. I am considering the motion from right away from A to C. Right away from A to C. Now see, we have to find the final velocity. We have the initial velocity. Now see, what is the initial velocity at A? Sir, it is plus 5 meter per second. Yes or no? Because it is thrown in the upward direction. Okay. Okay. Final velocity we have to find. What is the displacement, sir? Displacement is, so the height of the tower is given to be 20. So the displacement is minus 20 meter. Do you agree to it or not? How come the displacement is minus 20, sir? How come the displacement is, so I don't need displacement right now. Okay, I don't need displacement right now. Okay, so we have VU. No, I'll be needing the displacement now. So it is going to be minus 20. Acha, acha. ठीक है. Good, good, good. Okay. So now from A to C I have considered now. So from A to C, so it is going to be minus 20. It is going to be minus 20 meter. Why I am considering minus 20? Because displacement from A to C, it is in the downward direction. It is in the downward direction, beta, isn't it? Wonderful. So we can apply which equation? So V square is equal to u square plus 2as plus 2as. So what is this v? We have to find it. What is this u? So this is 5 square. This is plus 2. A is always minus 10 in this case because it is acceleration due to gravity. So this is going to be minus 10 and the displacement is minus 20. Minus 20. So it is going to become, see, 2, 240 and 400, 425. Okay, 425, isn't it? 425. Do you agree or not? Okay, so it is going to be v square is 425. So v is going to be root over 425 meter per second. Okay, 425 meter per second. Is it fine, beta? Please answer me. Yes or no? Please give me yes or no. Right? Yeah. Wonderful. Okay. Okay. So we have the magnitude of the. So this is its speed only. If velocity is asked, it would be minus root over 425 j cap. So since it is written as a speed, you just good to go with the magnitude, isn't it? Yeah. Haha. That is what I am saying, she said. If velocity would have asked, so you must written minus root 425 j cap. That would be the right way of it. Vector. Whenever you are representing a vector, we very well know that we require is magnitude, we require is direction. Yes or no? Okay. See, Erodove is an excellent book. Okay. But for NEET examination, I believe that you can watch the sections right away. See, this is how one must prepare for competition. If you are preparing for teaching, then Erodove is the best. Okay. But when you are, preparing for some competitive examination, you need to save time also. Are you getting my point? So, like for example, if Erodo, what you can do, see, this is my suggestion. Okay, you may follow it, you may not follow it. So I never recommend Erodo for reading the theory out of it for the NEET aspirants. If you are going for JEE advanced, then you can do. But for NEET, it is not recommended, according to me. Right? It is a book, beta. It is a famous book of physics. Okay. Okay, so let's add on one more part to it. Let me add on one more part to it. So, see, it depends. See, purpose is depending upon. So, see, what I am trying to say, see, I'll just explain. I'll write this question taken to reach graph. So, my dear, see, what I believe now, in competitive examination, you must be good at physics, chemistry, and biology, both all these subjects. And the quantum of the syllabus is very vast. Now, if you are reading a very good book, that is a good thing, of course, but the problem is that in competitive examination, we have to be quick also, okay? We have to remember multiple concepts as a day. So what happens? Like how it is different from our board examination or the school examination. So you never have the physics, chemistry, biology examination together on the same day. Do you have that? No, sir, of course not. But here in this, you are having all the concepts used on a single day, right? So, see, what I recommend that you, if you are preparing for competitive examination, you always have to study a subject like this. You must always converge, you must not diverge. Okay. Though if you have the interest, you can always read. So see, first you get see what I can tell you here is like this is something very practical, beta. See, you know the physics. Don't take it otherwise. No matter how much you know the physics, if you don't get selected in the NEET examination, you won't get a good MBBS college. Then nobody is going to believe you that you are a good at physics. Okay, you please understand this. I'm saying I'm very good at physics, and I have studied some from some local engineering college. Right? Would you believe on me? Sir, if you would have been so good at physics, why wouldn't you crack that examination? Right? Isn't it? Is it practical or not? Right? So, whenever you are not at some good place at some point of time in your life, you are not going to be called upon as that. It happens. This is something very practical. Say, I studied from Indian Institute of Technology, Roorkee, right? If I would have studied from some local government college or some local private college, would you be would you be considering me like I am very good at physics, right? Okay. So see, in competitive examination, you always must study in a way that you are taking all the subjects in a good flow. Okay. I'll just check. Yeah, yeah. After MBBS, you can read anything, beta. Okay. Why Erodo only? You can have to each of the topic there is specialized books. Like if you want to go for the mechanics part, this part of this course, you can refer Timoshenko. It's a very 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 amazing book. Uh, See, I don't have exactly the answer. I think we'll see. Okay, for thermal sciences, you can refer Senchel and Bowles. Okay. For fluid mechanics, there is a book, Indian author K.N. Modi. Wonderful book. Okay. Right? Okay. So see, after you into some place, no, it's not like that, she said. Okay. So firstly, you have to get to an entry point. See, many doctors are becoming, civil servants these days. So it doesn't matter. It doesn't matter. Right? What you study. So see, you can always do all these things, but after that, अच्छा, find root for 425. Okay, that's okay, she said. Let me solve this question. See, what I believe, like after getting through the competition, you can do anything, but before that, you must be careful that whether something you are reading is going to help you in the examination or not. That is my ultimate, advice to you. Now, find time taken to reach the ground. So, what is the time taken to reach the ground? So, we are considering again the motion from A to C, right? A to C. Okay, we are again using the motion from A to C. So time we have to find. So what is the initial velocity, sir? What is the initial velocity, sir? So initial velocity is equal to plus 5 because it is in upward direction. What is the displacement, sir? It is minus 20 meter. Sir, we require the time and acceleration is always negative. So this is minus 10. See, now one student can do this. Many students do this way. They first calculate the time from A to B. Then they calculate that time from B1 to A1. Then they calculate time from A1 to C1. You don't have to do. You always use the equation of motion from the ultimate initial position to ultimate final position. That's all. Okay. Okay. So see what we have. So S is equal to ut plus half a t square. So S is equal to ut plus half a t square. That is minus 20. U is plus 5 of t. This is half minus 10 of t square. So from here we'll have a quadratic equation. So minus 5 of t square plus 5 of t, okay, is equal to minus 20. So I may write 5t square, or I may write, so I'll divide this whole equation by 5. I'll be getting t square minus t minus 20 is equal to 0. Right, beta? So we can solve this quadratic equation. Can we or can't we? Can we solve this quadratic equation? Right? Sir, we cannot solve. If you cannot solve, na, don't put your mind much. Use this equation. We read in the 10th class minus b and plus minus under root b square minus 4ac upon 2a, right? Right? Okay, isn't it? No, see, you apply the. I don't do the calculation. Whatever it must be, you can put the values. You can solve the quadratic equation, isn't it? Put a is equal to 1, b is equal to minus 1, and c is equal to 20. Right? Okay, this much we can do now ourselves, because I want to save some time. I can get you another question in the time being. Right? Yes or no? Wonderful. Shall we move forward? So, did you get the same equation or not? T square minus t minus 4. Right, right, right. My bad. I always make such mistakes. This is 4 because we have divided it by, 20. Right? We have divided by 20. Oh, sorry. We have divided by 5. Right? Okay. Okay. Right, Buddha? So let's solve one more question then. We can find the solution of it. Do you want me to do it or what? Let me check the answer once. Huh? So whatever is, because I'll give the answer. Okay, whatever. Okay, don't do it. I won't do it then. Okay, so we'll be able to solve it. No problem at all. Okay, so let me come up with one more question. So we have. Actually, remember one thing. When you solve this question, you will get two values. I'm very sure one is positive and one is negative. Okay, one is positive, one is negative. So which value? Okay, let me solve it. So, so when you solve this, I'll just solve it, this by putting the data. So I think when you solve it now, you are getting t. You just cross check this. I just solved it using, just to save some time. I solved it using the uh, quadratic calculator. So now this is t is equal to plus 2.56 and t is equal to minus 1.56. So out of it, obviously this cannot happen. Na? This cannot happen. So what is the answer you must choose? This must be your solution, no? Right? This must be the solution. Yes or no? हाँ मतलब एक्चुअली देखिए क्या होता है ना दोस्त, जैसा आप कह रहे हैं ना, ये बिल्कुल सही बात है, मैं भी आपको यही बोल रहा हूँ। ठीक है, क्योंकि देखो ऐसा टीचर नॉर्मली हम लोग ये सोचते हैं कि जब आप नीट के लिए पढ़ रहे हैं तो आप नीट के लिए पढ़िए। ठीक है, जब आपको फिजिक्स में रिसर्च करना है, जैसे मुझे रिसर्च करनी, मैंने पीएचडी की भाई, मैंने मास्टर्स ऑफ टेक्नोलॉजी किया, मुझे पसंद था, मैं गवर्नमेंट जॉब में था, गवर्नमेंट जॉब छोड़ी, गवर्नमेंट जॉब छोड़ करके मास्टर्स करने आया, फिर मैंने पीएचडी की, मैंने रिसर्च पेपर्स लिखे। ठीक है, तो देखो किसी इंटरेस्ट को परस्यू करने की एक सिचुएशन होती है, एक पोजीशन होती है, एंड देखो कहो ना कहो इंडिया में तो सिचुएशन यही है ना मेरे भाई। ठीक है, आप बताइए, आप फिजिक्स में बहुत अच्छे हो जाएंगे, आप उसका फ्यूचर में कैसे यूज कर पाएंगे, ये क्वेश्चनेबल है। इन जनरल कॉन्टेक्स्ट थोड़ा मुश्किल है इंडिया में इस तरीके का हो पाना। व्हाट वी कैन डू अबाउट इट ना, है ना? आप कहीं बाहर होते तो वहां पे ऐसा होता कि चलो ठीक है भाई, आप फिजिक्स कर रहे हो, 16 साल में आपको ऑक्सफोर्ड बुला लेता। लेकिन यहाँ तो नहीं होता ना, यहाँ तो आप कहो मुझे फिजिक्स बहुत पसंद है, आईआईटी में जाओगे, गेट से गार्ड भगा देगा भाई आपको। ये फैक्ट है भाई, समझ रहे हो बात को? ठीक है। हाँ, तो ये minus is not possible. So let's do one more question. So ball is thrown. a ball is thrown upwards, upwards at a speed, definitely you can do. But for that, you have to pass some barriers, my dear. This is what I'm trying to explain to you. See what happens now when you enter. So do you believe that in Indian Institute of Technology, Roorkee, a lot of work is happening in the field of medical also. So when you are in a premium institute, na, it hardly have a barrier, right? You have a lot of exposure. Okay, so after MBBS, you can do MS also, and after that, you can pursue research in some particular field. Many people do that. Okay, physics is very applicable in today's context of medical science, right? Like as an engineer, I know, like for example, see implants, dental implants. Every day, new thing is coming into this. That titanium material is used, bone implants. Okay, many things, human kinematics, right? So physics is very much applicable to the medical sciences these days, right? So it's a good thing. I'm not against it, but what I'm trying to tell you as a teacher, that first pass that barrier. Afterwards, the world is open to you, my dear. Okay, like in MBBS, after MBBS, guys, so many people are doing, so many Bollywood actresses are like doctor, right? What? A ball is throwing upward. In this question, a ball is thrown upward at a speed of 28 meter per second. Find the speed of the ball before reaching. Before reaching. Oh, it is 1 second, not 8. Sorry. I read the question. I was talking to him, na. Yeah, it is 0. 1 second before reaching maximum height. Yes, my dear. Okay. And as this is quite unfortunate also. Like in India, we have a certain education system, isn't it? Like we cannot bypass it. We have to be a part of it. Okay. Now in the current education system that we are following in our nation, it is like this only. Okay. There's nothing wrong in it. Somebody don't sue me for this. Okay. But this is the fact, what you are trying to say doesn't fit in our system of education at this moment, right? So you have to cross up, you have to, go a certain way. Very nice. So very simple question. Very simple question. It says a ball is thrown upwards at a speed of 28 meter per second. Find its speed of ball 1 second before reaching minus height. 1 second before reaching maximum height. Right? Okay. Now please understand this. A ball is thrown upward. So let's suppose this is A and it reaches the maximum height at B. Okay, it reaches the maximum height at B. Now, 1 second before reaching maximum height. So first thing that we must know that what time it takes to reach the maximum height, isn't it? Right? What do you say? First thing that we must know that what time it shall take to reach the maximum height. Now, for that, I'll be applying the equation of motion from A to B. I'll be applying the equation of motion from A to B. Okay, now from A to B, when I say what is the initial velocity, it is 28 meter per second. You see, she said there are lot of options, lot of options these days. Okay, but for that you have to reach a certain level. Are you getting my point? Okay. See, you have done, you like try to understand this. All of you entered MBBS in AIMS Delhi. Okay. No, it is a stamp that you are better than an ordinary student or an ordinary person. Do you agree to it or not? Now, being into AIM, you say some random thing that also makes some sense. Are you getting my point? Okay. See, I'll tell you what. When I say that I am Dr. Umashankar, I belong from IIT Roorkee, and then if I say that I want to, pursue for the NEET examination, then you think that a person from IIT is saying something like this, right? There must be some sense to it. So what I'm trying to tell you, when you are in such a position, you are doing MBBS from AIMS, that is a big thing. It adds so much of credibility to you. You come up on YouTube, you start saying something. Okay, I am at AIR1, right? And I want to apply physics in this. So many people will come to support you. They will start telling, okay, the education system like this should be like this. This happens now, this way. So that is why for that you have to cross a certain barriers first. Then only you will have to be in that position. Okay. So you must make targets like that. Okay. See, if you like imagine so many things at a time, this doesn't work. Right? Lately, if you want to become the Prime Minister of India, that is also possible. Na? So many politicians are doctor only. So many politicians are engineer only. See, but they have crossed a certain barrier. Are you getting my point? So life is open to you. You have just started your journey of life in a way, right? But one mark you have to do so that you get into a position where when you say something, people don't feel that you are talking rubbish. Simple as that. I'm glad that some of your problems is solved with this talk. Okay, let me come to the point then. Okay, because we have to go into the aims, right? Now for that, let's get back to this. So A to B. So A to B. Okay, so we are considering the motion from A to B. So velocity, initial velocity is 28, the final velocity is 0, acceleration is going to be minus 10 meter per second square, minus 10 meter per second square. Now from here what is going to happen? So we can write v is equal to u plus 80, isn't it? So final velocity is 0, this is 28, this is going to be plus of minus 10, this is going to be t. So basically it took 2.8 seconds to reach the maximum height. It took 2.8 seconds to reach the maximum height, isn't it? It took 2.8 seconds to reach the maximum height. Okay. Now it says find the speed of the ball 1 second before. Find the speed of the ball 1 second before reaching the maximum height. 1 second before reaching the maximum height. So 1 second before reaching the maximum height, that means uh, so it is 1 second before. So that is, yeah, we need to find in 1.8 seconds. Okay, so what is going to be the time at that moment? It is going to be 1.8 seconds. Okay, 1 second before reaching maximum height. So basically what happens? So see, let's try to understand this. So see, this is the building. This is the building. Okay, now from this position to this maximum position, it took how many seconds? 2.8 seconds. Okay, now we need to find, so in 1.8 seconds it would have reached, let's suppose, C point. Okay, now between A to C, so what is asked in the question? What is the velocity? So if I apply A to C, so now we have the initial velocity, that is plus 28. We have the initial velocity, that is plus 28 meter per second, right? Acceleration we have is minus 10 meter per second square, because it is downward always. Now the time is 1.8 seconds, so you can get the final velocity, right? Very easily, sir, we can get. So final velocity is equal to u plus 80. U plus 80. So this is going to be plus 28 plus minus of 10, and t is 1.8. Okay, so this is going to be plus 10 meter per second we are getting. Okay, plus 10 meter per second we are getting, and obviously this is speed. Obviously this is the speed, right? not the velocity. If velocity would have asked, it would be plus 10 j cap, isn't it? Okay, okay. Did you get this? Please answer me. Did you get it or not? Okay. Well, let's try one more question. Chalo, let's try this one. I'm very sure we can do. If you understand the question, you will be able to solve it. Physics questions sometimes sound very interesting, like some this happens, drop off, tap, and like that. Please do it. Very nice, Vila. Wonderful. No, very interesting questions. So, see why they sometimes make questions this way. Okay, so see, this is for the very reason that see this question kind of these questions sounds very different. Like a tap is the water is dropping from the tap. So the physics problem, more practical it sounds, students feel more difficulty in solving them. Okay, so that is why these questions are like in fashion. Okay, so we have uh we have a you know a tap. Let's suppose we have some tap here. We make a tap. Does it look like a tap? Okay, somewhat it is looking like a tap. Now some drops are dropping. So our tap drop water drops at 1 second interval. So let's suppose this is the first drop. And see, at this instant, sixth drop is just coming out of the tap. So this is the sixth drop, right? This is the sixth drop. So this would be the fifth drop. This would be the fourth drop. This would be the third. This would be the second. Okay. This would be, the second. This would be, or I'll just make to the third drop. So this is the sixth, fifth, fourth, and third. Do you agree or not? Please answer me. Sixth, fifth, fourth, and this one must be the third drop. Isn't it? Yes or no? Do you agree or not? Okay, wonderful, beta. Okay, wonderful. So now please understand this. Now what is the information is given? So find the distance between the third and the fifth drop. Now if I say this is the distance of the tap to the fifth drop, let's suppose this is H5, and to the third drop it is H3. To the third drop it is H3, right? Fifth drop, and this is the third drop. So they are asking you H3 minus H5. Acha, motion is in 1D is your favorite. It is about to finish now. Like with this section, with this question, this chapter will be completed. Sorry, this motion under gravity will be completed, and we have one more topic, relative velocity in one dimension, that we'll do tomorrow. So motion is a straight line will be completed. Vectors, projectile motion is like combination of, you know, this motion in a straight line and the vectors, right? So that is also going to be completed like in very few days. Okay. Okay, so it is going to be completed. Then I'll have to take two sessions. I am told to do so. One complete, one short chapter for kinematics and one short for vectors. So our day will be taken in that also. So because vectors we have done in so many sessions now, so we'll have to make one video in which we complete the vector, not the whole thing, but summarized way, revision way. Okay. So these two sessions we'll have to do, and afterwards we'll have to start with the project time, right? Okay. Now see, so how we can going to do it? So let's talk about the third drop. Yes, see, she say that is again see what I would say. See, you are not preparing for that thing now. If you would have preparing for that thing, I would have been telling you some more things, some more typical question. This is, a established fact, right? Okay, that is why that is JEE advanced, and that is whole solely depending upon physics, right? They are going into the field of engineering. You very well know engineering is what it is, extension of the physics basically, right? So they are expected to learn, understand more of the physics than the NEET aspirants. So that is why the level of the preparation of this particular subject differ drastically for JEE and for NEET, right? But I think mains question you must be able to do. Mains question, most of 90-95% of question you must have been able to do in one go. Isn't it? Am I wrong? Advanced question level is different, but for mains, I think that would be like that. Yes or no? Am I correct or not? Now let's talk about this. So now H3 can we use U plus, yeah, means you have done it all. So very nice. So H3 is equal to U plus UT plus half AT square, UT plus half AT square. Okay, good. So what is this H3? So what is the initial velocity? So let's focus on the third drop. So when I focus on the third drop, the initial velocity would have been zero only. Every drop will have the initial velocity to be zero. Plus half, what is the acceleration? Acceleration is always in the minus. And what is the time? Okay, so time, how much time it is going to take? So see, 1 second, 2 seconds, 3 seconds. So this is going to be 3 seconds. So how come? Now please understand the sixth drop is at the tap. Okay. Now it takes 1 second interval for each drop to come out. So sixth drop, so fifth drop would have in motion from 1 second, fourth drop would have been in motion for 2 seconds, third drop would have been in motion in 3 seconds for 3 seconds. So we'll be writing 3 square here. We'll be writing 3 square here. So we are getting H3 is equal to how much? So 9 by 2 for 45 meter, minus 45 meter. Why it is minus? Because see, from reference it is in downward direction. Now similarly H5 if we speak of, so UT is again going to be 0 plus half, acceleration is always 10. And now this fifth drop is how in time it is how much far from the tap. So it must have taken 1 second. Okay, fifth drop would have been in motion from 1 second, right? So this is going to be your H5. So H5 is going to be minus 5 meter. minus 5 meters. So what is the difference between H3 and H5? So H3 minus H5 is going to be how much? It is going to be minus of 40 meter, isn't it? Or just 40 meter because you want to have the difference. Okay, 40 meter. Is that fine, brother? Please answer me. Right? Right? Yes or no? So I hope that so we'll do some questions in the 75-day challenge. Okay, I have left with some questions in vectors also that we need to do. We need to do some of questions of these also, right? Okay, okay. So we'll keep it to this point in this session. We have completed the motion under the gravity in this session. So just one topic is left in motion in a straight line, that is the relative velocity in one dimension. And I'll complete it in one go, very small topic. Then we'll move to the motion in a plane and projectile motion, circular motion and all that. Okay. Okay. So now we have one more, domain open for us. We can now solve. So if you see the PYQs, we will have a lot of questions from these contexts. Okay. From these. Okay, okay, Shri. Thank you very much. So I'll keep it to this point. So the new students who have joined the session or maybe watching the recording later, I request you to please subscribe the channel. Please like the video, share to your friends also. And I'll keep it to this point. So with this, thank you very much. Have a good day and we'll see you in the next session.